Hey guys, today we're going to take a look at what's called the real number system. And all I want to say before we get started is these are just ways of organizing and naming the numbers that we're used to seeing. So, first, I want you to pause your video and draw this table or this chart. Now that you've drawn this organizational or graphic organizer, let's talk about what each of these mean. First of all, every single number that we're going to talk about today is called a real number. Okay? That's every single number you've ever encountered in your life. But now let's take a minute and look at natural numbers. So natural numbers are the numbers you first encounter like when you're a baby. Numbers like 1, 2, 3, 4, and so on. And I always like to think about cookies. When you're little, you say, Mom, can I have 2 cookies? Or can I have 1 cookie? These are the numbers that come natural to us. Then, when we add the number 0, 1, 2, 3, 4, that becomes a whole number. So the next label in our number system is whole numbers. Now we pull in stuff like our perfect square roots of perfect squares. The square root of 9 is 3. 3 is a whole number. Decimals that look like this, 7.00. That is a whole number because there's nothing after the decimal. Even fractions that reduce to a whole number, we call them whole numbers. 4 divided by 2 is 2. So 4 over 2 represents a whole number. Now let's go up and talk about integers. Integers are when we bring in negative whole numbers. So -2, -1, 0, 1, 2, and so forth. All of those are integers, positive and negative whole numbers. So when we look at something like this, negative square root of 49. What's the value of negative square root of 49? -7, and -7 is an integer. What about this? -10 over 5. That simplifies to a -2. -4, +12. All of these are examples of integers. Okay? So things that their value is a positive or negative whole number, those are integers. Now let's go to this next word. Now all of these integers, whole numbers, and natural numbers are also rational numbers. They're also real numbers. But in rational, let me get a different color here. When we talk about rational numbers, these are all the numbers we have left. Like if it's a fraction that can't be reduced to a whole number or an integer. Negative 4/5, that's a rational number. Even numbers that are repeating decimals. And I want you to label that because that is very important. Repeating decimals, that's the pattern, a common pattern. Those are rational numbers. That's kind of the definition of a rational number. A fraction or a repeating or terminating, here's another word, a terminating decimal. That means it stops. So let's write that. Like 1.3 is an example of a terminating decimal or a decimal that stops. All of those, we can only call them rational. But like the number 3, it's a natural number, it's a whole number, it's an integer, it's rational, and it's a real number. So we're just talking about different ways to label our numbers or name our numbers. Now let's talk about this one over here. Irrational. So we've got all these are rational. Let's look at the crazy ones that are irrational. Let me get a different color for this. What's something we've not used? I've not used purple yet. So irrational numbers are our Let's talk about something we've looked at recently. Square root of 46. That is a square root of a non-perfect square. So that's an irrational number, because if we change that to a decimal, it would be something like 6.2137459. It wouldn't stop. The decimal wouldn't stop, and it wouldn't have a repeating pattern. So it's irrational. Even stuff that looks like this. Square root of 2/3. That's a fraction, but it's the square root of a non-perfect fraction. This one is the most popular. Pi, if you'll remember, is about 3.1456, and it just keeps going. It doesn't repeat, it doesn't stop. That's usually what that ... means. Here's another example. 0.10, 100, 1000, and it just keeps going. Looks like there's a pattern, but it's not. You have 1 0, then 2 zeros, then 3 zeros. So these are considered irrational numbers. Let me give you another one. Negative square root of 5. Over here, we said the negative square root of 49 is rational, or it's an integer because it's -7. Think about this. Negative square root of 5. Is 5 a perfect square? No. So slapping a negative in front of it doesn't make it rational. It's still irrational. And I think of irrational numbers as crazy numbers, because if you change them to decimals, they don't repeat and they don't stop. So let's write that down. Decimals that don't repeat and don't stop. So that's what makes a number irrational. So we're going to practice a couple of these so you can see what we're doing in this lesson. We'll do first example. How would you label -9? What's the best way to label -9? Well, it's rational. You can say that. What else? How about it's an integer, because it's a negative whole number? Is it a whole number? Well, no, because if you look, whole numbers are only positives. And it's not a natural number, again, because it's negative. Let's try another one. What about 4/9? How would we label this? Well, let's look. It's a fraction, and it can't reduce to like a whole number or an integer. So we would simply say this is a rational number. And we're going to use this graphic organizer to help us. Let's keep going. What about this one? Square root of 2. Well, it's not natural. It's not a whole number. It doesn't reduce to an integer. Why? Because it's a square root of a non-perfect square. So the only thing I can say about this is it's an irrational number. Let's keep going. Let's do just a couple more so you can see how you're going to use this graphic organizer. How about -16/2? Well, first of all, a fraction represents division. What is -16 divided by 2? -8. So let's talk about it. First of all, I always like to start at the top. That helps me. Or you can start at the bottom of your graphic organizer. It doesn't matter. Is it rational or irrational? Well, it's calm. It's a negative whole number, so it's rational. If it's rational, then is it an integer? Yeah, it's a negative whole number. Is it a whole number? Well, no, remember those are only positive, so I'm finished. Let's try one, maybe two more. What about this? What if I write the number 4? As a matter of fact, I'm going to change that. What if I write the number 24? First of all, is it rational or irrational? Remember, irrational numbers are crazy numbers. They have crazy decimals that don't repeat or don't stop or terminate. So no, it's rational. And now let's look under rational. Is it an integer? Is it a positive or negative whole number? Yup. Next, is it a whole number? Is it a positive whole number? Yes. Oops. Put well instead of whole. And is it a natural number? Like, is it a number we would use to count things? Yes. So 24 is all of these things. It's rational, integer, whole, and natural. Let's do one last one. Let's say I give you this. .6489213 ... Is it rational or is it irrational? Well, let's look. It's a decimal. Does it repeat or does it terminate? No, there's no pattern. And that ... says that craziness keeps going and going. So all I can say about this number is it is irrational. So I want you to use your graphic organizer and these examples to help you with your practice. Talk to you guys soon.